Right, let's continue on to the real binomial theorem. Right, the binomial theorem. Well, what is the binomial theorem about? Naturally, it's about binomials, but what is a binomial? Okay, well, x plus y to the 0, that's just 1. X plus y to the 1, that's just 1x plus 1y. There's a reason I'm writing all of this like this. X plus y squared is x squared plus 2x y plus y squared. All right? X plus y cubed is x cubed plus 3x squared y plus 3xy squared plus 3y cubed. All right? And I'll do one more. X plus y to the 4th is x to the 4th plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus x to the 4th. Oh, I'm sorry, I made a mistake here. This should not be a 3. Okay. All right, great. So why am I talking about this? Well, these are binomials. And the binomial theorem talks about how to expand these binomials. I'm sure we've all been in a situation on a test, on an exam, where we had to do something like x plus y cubed, and we thought, well, I wish there was an easy way to do this. And the binomial theorem tells you an easy way to do it. So what I'm going to do is I'm just going to look at these coefficients here. I'm just going to isolate them. Well, this is, sorry, I didn't write these ones here. I should have. I'm going to look at all of these coefficients here. I'm just going to isolate them and see if I can't find a pattern. Okay, let's see. Well, this is what that would look like if I were to just isolate them. And maybe you can see the pattern here. I'll give you a minute. You can pause the video and try to figure out what is the next line going to be. Okay, I'll tell you now. So, on the sides you always have 1s. To get the next element, you just look at the 2 above it. So to get 3, I did 2 plus 1. To get 6 here, I did 3 plus 3. So to get the next element here, I'm going to do 1 plus 4, which is 5. Okay, let me erase these marks so it's a little clearer what's going on. And then here I'm going to get 10. Here I'm going to get 10. Then between these two I'm going to get 5 again. Hopefully that's clear what's going on. So you just take a triangle like this to get the next element. And there's always 1s on the side. So to do the next one, you do, all right, this is 1 plus 5 is 6 here. 5 plus 10 here is 15. 10 plus 10 is 20. Here you'll get another 15, and then here you'll get another 6. So it's very symmetric, actually. This is a very nice triangle with all sorts of properties. It's called Pascal's triangle. I don't know that Pascal invented it. I've heard things that he got it from China, but anyway, it's called Pascal's triangle. Pascal's triangle, and it can be used to expand binomials. I think Isaac Newton discovered the binomial theorem when he was working on calculus, when he was trying to invent calculus. But why is it helpful for us? Well, as you can see, these coefficients correspond to Pascal's triangle. And so if I want to get these coefficients, all I have to do is know how to use Pascal's triangle. All right, so I'll do an example here of a very difficult polynomial to do. So this is going to be x plus y cubed, sorry, not cubed, to the 5th power. And to do that, well, remember when I told you in class that you should always start counting at zeros? How many unicorns are there at my desk? Let me start counting. Okay, 1. That doesn't make sense. You don't want to do that. You want to start counting at 0. Okay, how many unicorns are there on my desk? Well, there's 0 unicorns. Okay. So you start counting at 0. So this actually corresponds to the 0th row. This corresponds to the, I like to say the 1th row, or the row 1. This will be the row 2. This will be row 3. This will be row 4. And this will be row 5. So to do x plus y to the 5th, we need to go to the 5th. We need to go to row 5. Even though that's the 6th row, if you were to count 1, 2, 3, 4, 5, 6, let's say it's row 5. Let's just start counting at 0. Let's all agree to start counting at 0. This is 0. Okay, fine. So how will I do this? Well, I'm going to show you, and hopefully you'll get the pattern. And if not, I'll make it explicit. So the way you do this is you start off with x to the 5, y to the 0. So this is 1x to the 5, y to the 0 plus, and then you go on to the next element here. That tells you the next term. Hold on, let me actually write this a little nicer. So the next coefficient will be 5, x to the 4th, y to the 1. Next coefficient will be 10, x cubed, y squared. Hopefully you see what's going on with these powers. Next one is going to be 10x squared, y cubed. This one's decreasing, this one's increasing. Next one will be 5x, have I got this right? Yes, x to the 1, y to the 4th, and the last one will be 1x to the 0, y to the 5. But x to the 0 and y to the 0, those are just 1. So those are just 1. And I don't have to write the 1s every time, so I'm just going to simplify this to be as follows. Y squared plus 10x squared, y cubed plus 5x y to the 4th plus y cubed. That's the answer. That would be the answer. And that's much, much easier than multiplying x plus y by itself 5 times. I would probably make a mistake if I were to do that, but this is a nice, clean way to do it. Okay, but what does this have to do with summation notation? What does this have to do with n choose k, the thing that you just introduced us to? Well, that is the binomial theorem. Binomial theorem. Let's get to the statement of the binomial theorem. If you have x plus y to the nth power, that is going to be the sum from k equals 0 up to n of n choose k, x to the n minus k, y to the k. I know you're looking at that and you're really scared. That looks crazy. But I promise you it's actually not bad at all. Let's do an example. Let's just do an example and you'll see what I mean. So let's just plug in 4. X plus y to the 4th power. Let's say my n is 4 here. So this is saying take the sum of k equals 0 to 4, from k equals 0 up to 4, of 4 choose k, x to the 4 minus k, y to the k. Now this is something you need to memorize. You have to have this memorized. I won't give this to you on the exam. Even though I wish I could, I'm not allowed to. So you have to memorize this. Okay. All right, so now let's just do this out. If you don't understand sigma notation, now would be a good time. Go back and review the sigma notation video that I recorded. Okay. So now let's just start doing this out. This is going to be, so k equals 0, 4 choose 0, x to the 4 minus 0, y to the 0. I'm just plugging in wherever I see a k, I'm plugging in 0. Next, I increment, so I finished plugging everything in. I'm going to increment k. Now k is equal to 1. 4 choose 1, x to the 4 minus 1, y to the 1, plus 4 choose 2, x to the 4 minus 2, y to the 2, plus 4 choose 3, x to the 4 minus 3y cubed, plus finally 4 choose 4, x to the 4 minus 4, y to the 4th. Okay. All right, but this is, this is so cumbersome. Why would I want to do this? I have to do 4 choose 0 and 4 choose 1 and 4 choose 2. That's so much work. Well, actually, again, you can bring in Pascal's triangle. Pascal's triangle will tell you what those values are without need for you, without the need for you to compute it. Let me draw this a little nicer. So I'm going to go up to, so this is to the 4th power, so I'm going to go to row 4. Remember, this is row 0, this is row 1, this is row 2, this is row 3, and this is row 4. Okay, so this is row 4. Even though it's the 5th row, this is row 4. We're starting our count at 0. And also when we're on this row, we count at 0. So 4 choose 0, 4 choose 0 is actually 1. So I go to the 4th row and I start counting at 0. Okay, this is the 0th element of that row, 1. So 4 choose 0 is going to be 1. 1, x to the 4, y to the 0 is 1, so I'm not going to write that. And then 4 choose 1. So the element number 1 in row 4 is 4. I know it's the second element, but we start counting at 0. So it's 0, 1. So this is 4. X to the 4 minus 1 is 3. Y to the 1st. Plus, so 4 choose 2 is going to be 6. 6 squared y squared. 4 choose 3 is actually going to be 4. So this is x to the 1, y cubed. And then finally, let me pick a different color here. Finally, 1 is going to, 4 choose 4 is going to be 1. So plus 1, x to the 4 minus 4 is x to the 0, which is 1. So y to the 4th. And that would be the correct answer. That would be the correct answer. That would be it. Hopefully you understood that example. We will do another few, so don't worry if it's still a little unclear. I hope that it will, that the following examples will clear up any confusions. Okay, let's do another example. I would like to do, so for instance, you don't just have to do x plus y to the n. So let's do something like x plus 1 to the 3rd power. Let's do x plus 1 to the 3rd power without doing x plus 1 times x plus 1 times x plus 1. In this case, it might be easier, but just for the sake of an example, let's go through this one. Okay, so I know but the binomial theorem. I'm just going to state it. The binomial theorem says that x plus y to the n is the sum. Oops, sorry. You know, my computer is lagging a bit, so it's a little hard to draw. K equals 0 to n of n choose k, x to the n minus k, y to the k. But here I don't have a y exactly. My x is the same, but my y is 1 here. So when I plug that in, I just better be cognizant of that. So according to the binomial theorem, x plus 1 to the 3, if I just follow everything here, that's going to be the sum of k equals 0 to, my n is 3, 3 choose k, x to the 3 minus k, y, what's my y? My y is 1, so y 1 to the k. All right? So I'm not going to have to worry about that 1 term. I could cancel it out right now, but just so you see what's going on, I'm going to keep it there. Okay. So let's see here. Let's just start plugging values in. This, if I just plug everything in, this is telling me 3 choose 0, x to the 3 minus 0 times 1 to the 0, plus 3 choose 1, x to the 3 minus 1, 1 to the 1, plus 3 choose 2, x to the 3 minus 2, 1 squared, plus 3 choose 3, x to the 3 minus 3, 1 cubed. Okay, but I don't want to compute all of this, 3 choose 0, 3 choose 1, 3 choose 2, that's too much work. So I'm just going to use Pascal's triangle, the handy dandy Pascal's triangle. I'll put it up here in blue. Hold on here. And because this is my n is 3, I'm just going to go to the third row. This is row 0, this is row 1, this is row 2, and this is row 3. Okay. So let's see here. This is telling me, okay, 3 choose 0, that's just 1. This is going to be 1 times x to the 3 minus 0 is just x cubed. I'm not going to worry about these 1 terms, they're all just 1. 3 choose 1, 3 choose 1 is 3. So this is 3x squared. And then 3 choose 2 is 3. 3x. And then finally, 3 choose 3 is 1. X to the 3 minus 3 is x to the 0, which is just 1. So I'm not going to write that, and 1 cubed is 1. So I'm not going to write that. So finally, the answer is just x cubed plus 3x squared plus 3x plus 1. You might have found it easier to just do x plus 1 cubed out. It might have been, but this was just for illustrative purposes. I wanted you to understand what was going on. Now let's do a harder example where it might actually be worth it to use this method. Okay, so let's see, 2x plus y to the 4th power. Okay, let's compute this. I'm going to write the binomial theorem again. The binomial theorem, what does that state? That says x plus y to the nth power is the sum from k equals to 0 up to n of n choose k, x to the n minus k, y to the k. All right. Well, here, my x is not actually x. It's actually going to be 2x. And this will be my y. All right. So I just need to keep that in mind when I plug everything in. So 2x plus y to the 4th power will be, according to binomial theorem, when I plug everything in, from k equals 0 to 4, my n is 4 here, 4 choose k of, again, my x is 2x here, so it's going to be 2x to the 4 minus k, y to the k. My y is actually just y here. Okay, good. And now let's just expand this out. So this is going to be equal to 4 choose 0, 2x to the 4 minus 0. And by the way, guys, you might be really fast and cool, but I'm really slow and lame, and I think that's the best way to do it. So try to follow my steps exactly. Try to plug things in, be very methodical about it. Don't go too quickly because you're bound to get an error, all right? So just do it this way. I know it's slow, I know it's tedious, I know it's not that much fun, but please do it this way. I think doing it this way will help you on the exam a lot, okay? So 4 choose 0, 2x to the 4 minus 0, y to the 0, plus 4 choose 1, 2x to the 4 minus 1, y to the 1, plus 4 choose 2, 2x to the 4 minus 2 y squared plus 4, choose 3, 2x to the 4 minus 3 y cubed plus finally 4, choose 4 of 2x to the 4 minus 4 times y to the 4th. Okay, great. Now let's just, I don't want to have to compute what 4 choose 0 is every time, so what I'm going to do is I'm going to draw out my Pascal's triangle up until I hit row 4. All right. And, okay, great. So I know that 4 choose 0 is 1. So this is 1 times 2x to the 4th. Well, 2x to the 4th is going to be 2 to the 4th, x to the 4th. So I'll just write that out. 2 to the 4th, x to the 4th. Y to the 0 is just 1. So I'll write that out here. I'm going to have a third intermediary step. Okay. 4 choose 1 is actually given here. Remember, we start counting at 0. So this was 4 choose 0. This is 4 choose 1. So that's 4. 2x to the 3rd is 2 to the 3rd, x to the 3rd. And there's just y to the 1 there. Plus 4 choose 2 will be 6. So this is 6 times 2x squared is just going to be 2 squared x squared. Hopefully that makes sense, all the arithmetic that I'm doing. And then there's a y squared term. And then we have 4 choose 3 is 4. So that's 4 times 2x to the 1 is just 2x, y cubed, plus, and then 4 choose, let me pick a different color here. 4 choose 4 is 1. 1 times 2x to the 4 minus 4 is 2x to the 0, which is just 1, y to the 4th. Okay, and now I'll just compute everything. So 2 to the 4th is 16. This is 16x to the 4th. Oops, there should be a plus sign here. Plus 2 cubed is 8 times 4 is 32. So 32x cubed, x cubed, y to the 1, perfect. 2 squared is 4, 4 times 6 is 24, so 24x squared, y squared. 4 times 2 is 8, so 8xy cubed, and then just plus y to the 4th. All right, and that would be the answer. That would be the answer. Sorry, my computer's lagging a bit. Okay, good. So hopefully that was clear how we did that. That's a pretty fun problem, in my opinion. Let's do 2 more problems. So here, I wanted to go over something like this. Why is this useful? Let's say that you're dealing with binomials, but you only want to know the nth element of the binomial. So, for example, if you have x cubed plus 3x squared y plus y cubed, let's say you have something like this, right? Oh no, sorry, 3xy squared plus y cubed. Let's say you wanted to know, what is the third term? What's the third term here? Well, the third term is 3xy squared. Let's say you didn't want to know the rest of these guys. Well, I'll put it to you like this. The r plus 1th term of a binomial will be given by n choose r, x to the n minus r, y to the r. So for example, find the third term in 3x plus 1 to the 5th. Find the third term in 3x plus 1 to the fifth. Well, here, if I'm trying to find the third term, that's the 2 plus 1th term, right? Because I know the r plus 1th term is given as this thing. So what this is telling me is I need to do, and my n is 5 here, so I need to do 5 choose 2 of, here my x is 3x, and here my y is 1. So I need to do 5 choose 2, 3x to the 5 minus 2. Oops. Sorry, why did I put y to the third? It should be y to the r. So y 1 to the third power. So that's how you do this one. Okay, what is 5 choose 2? Let's figure that out. I'm just going to draw my Pascal's triangle here. This is 1, this has to be 5, this has to be 10, 10, 5, and 1. And I want 5 choose 2. So remember, we always, this is row 5, but we always start counting at 0. So this is 0, 1, 2. So 5 choose 2 is actually going to be 10 in this case. So this is 10 times 3x to the third is 27x to the third times 1 cubed is, I'm sorry, this should be 1 squared. It doesn't matter, but this should be 1 squared because r here is actually 2. That's the only confusing part about this problem is if you're on the nth term, if you want to find the nth term, you actually have to plug in n minus 1. Okay. 1 squared. So this is 270x cubed. So if you were to expand this thing out, the third term would be 270x cubed. Let's do another example. Find, what's going on here? Okay. Find let's say the fourth term of x plus 2y to the fourth. Yeah, let's try to find the fourth term of this guy. Well, the fourth term is the 3 plus 1th term. Okay, and I'm doing this because in this case, r is going to be 3, not 4. So this is according to the binomial. So according to the binomial theorem, we need to use this. N choose r, x to the n minus r, y to the r. All right. Actually, I'm just going to write that here. N choose r, x to the n minus r, y to the r. What is my x here? Well, my x is just x. That's fine. And my y is 2y, actually. So this is going to be equal to 4 choose 3. Remember, my r is 3. X to the 4 minus 3. Y to the 3. 2y to the 3. 2y to the 3. Okay. Well, let's compute what 4 choose 3 is. We could do that by hand, or we can use the triangle. I prefer the triangle. So I'm going to go to the row 4, and I'm going to count to 3, but I'm going to start counting at 0. So 0, 1, 2, 3. So that means 4 choose 3 is 4. Okay. 4 choose 3 is 4. X to the 1. 2y cubed, well, that's 8y cubed. Good. 4 times 8 is 32 xy cubed. So if we were to expand this thing out, we would find that the fourth term is this. Okay, so I hope that was clear. I hope these examples make sense. I do think that finding the nth term, I can tell you that that's going to be on the exam. So please make sure that you study this. Okay. All right.